Welcome, everybody, and thank you so much for joining us for today's webinar, Improve Your Testing with a risk-based analysis approach. I'm your moderator today. My name is Brent Jenkins. I'm the marketing manager here at Checkpoint Technologies. So I'll be doing the moderating, and joining me today is our presenter, Bob Cruz. Bob Cruz is the president of Checkpoint Technologies, along with the president of the Tampa Bay Quality Assurance Association and co-leader of the Florida Vivid chapter. Bob, you want to introduce yourself a little more?
Yeah, hi everybody, and thank you so much for joining us today. I hope you get a lot out of the presentation. Please feel free as we go to submit any questions. You'll notice there in your control panel that there is a section where you can submit any questions, and we will do our best to respond to everybody. If we're not able to do it during the webinar, then we will get the questions answered and send the questions and answers to everybody that attends today. And then, Brent, this is being recorded, correct?
Yep, I was actually about to do a little bit of housekeeping, so thank you for covering that, Bob. This is a live webinar, but we are recording it, so everybody who joined today or even registered will receive a link to that recording within about 24 hours. So sometime tomorrow you should receive that. And then, like Bob mentioned, we do have the questions panel. We have a questions section at the end of this webinar, so we'll get to as many as we can. If not, like Bob mentioned, we'll get to them in a follow-up email. So today we're going to be discussing a few things, and just to highlight some of the things we will be discussing, one of which is why you can't test everything. Along with that, we're going to discuss the value of performing risk analysis. And then finally, how to improve your testing with a risk analysis. So with that, I'm going to pass it over to Bob to start the presentation. Take it away, Bob.
Thank you very much, Brent. I appreciate that. So I've been in IT now for close to 29 years. I started off as an IBM DB2 COBOL developer, and then just a number of years ago, I developed a real passion for quality assurance and software testing. And today we're going to be discussing, obviously, risk-based testing, risk analysis, and without a doubt, this has got to be one of my favorite topics to present on and discuss. So, you know, obviously you cannot test a program completely. And there are three reasons why complete testing is absolutely impossible. One is that the domain of possible inputs is just too large to test. There are too many possible paths through the program to test. So think about all the different conditional statements you might have, the different branches, the different paths that the data can take or your navigation could take. And then in addition to that, the user interface issues are too complex. Now, I don't want to take credit for all this great information or that quote. That actually comes right out of a fantastic book, a well-known book, Testing Computer Software by Kem Kainer, Jack Falk, and Hung Wen. So, you know, our goal obviously is to improve the process. How can we improve testing knowing that we can never guarantee that we're going to find all defects? So, because our goal is to optimize, to hit that optimum point in regard to our testing initiative. So it's very easy as testers, you know, we want to do our best to find every defect that we can. We want to deliver software, perfect software. But at a certain point, the amount of testing that you start to do or that you're doing, it starts to exceed the cost of the software itself. So your goal is to hit an optimum there so that your cost of testing does not exceed the cost of the software itself to deliver that. So one way to do that is by improving the process. It's important to understand, though, however, to use a great quote by Warren Buffett, that true risk comes from not knowing what you're doing. So in other words, you've got to have a strategy, you've got to have a process. And that is why I want to discuss risk analysis, risk-based testing. And before I dive into that, I just want to share some quick terminology with you. So when we talk about risk analysis, keep in mind that whenever I use the term asset, I'm talking about an object, a specific asset. It can be a system component, data, it can be a requirement, it can be a test case, or even the complete system. So an asset, that has a pretty wide meaning definition. Impact or criticality. So we're talking about the impact or criticality to the organization. So in other words, if the risk that we're going to be discussing were to be realized, what is the monetary, reputation, overall risk to the organization? Is it a breach of law? Are we breaking a regulation? Are we going to cause negative public relations? And then there's probability, so also known as likelihood. So what's the likelihood that a given event will be triggered? And there are a lot of different factors involved in predicting or calculating the probability, and we'll be discussing those as we go. And then there's exposure. So exposure represents the number of users impacted or the importance of the users impacted. So in other words, let me give you a couple of examples. So imagine that if we had a particular risk, if it were to fail, we'll call it risk A. If it were to fail and impact 100 users at a financial impact of $1,000 per user, then that would total 100,000. So imagine that you've got risk B, where if it fails, it only has a cost of $100 per failure every time a user realizes that failure. However, it affects 2,000 users. So as you can see, because it impacts a greater number of users, the overall financial impact to the organization is significantly greater. And then another scenario is, imagine that you've got an application, a healthcare application, and let me compare two different applications. You've got one where it impacts the functionality of scheduling vacation or time off for the physicians, as opposed to an application that handles the prescription process for patients. Obviously, that latter scenario, impacting our actual patients, is much more significant to our organization. So asset, impact, probability, exposure, these are all terms we're going to be discussing further during today's webinar. So let me talk about some risk-based testing approaches, because we're going to hone in on one particular one, but there are three different approaches I want to discuss with you. So one is when risks are defined before all else. So in other words, our assets, our code, our applications, our test cases, etc., all evolve from the risk. So early on, we don't even have an application, so we might gather our team and say, hey, we need some kind of functionality to do this, because if we don't, here are the risks to our organization if we don't design and implement this type of an application. And we would define all of those risks, and then from that, our application and all of the other assets evolve. So that is what most individuals would say is true risk-based approach or risk-based development. And that is something you've got to start very early. The second type of approach is when risks are defined after the creation of the assets, and then you would then map all of the assets to the risk and adjust accordingly. So during today's webinar, we're actually going to focus in when risks are implied by the assets failing. So in other words, we've got our assets, and they might be requirements, they might be test cases, and we're going to take our assets after these have been designed and developed, and we are going to start performing risk analysis. And then as we're going through each of our assets, we would assign risk scores based on impact and probability. So we would look at each requirement or test case perhaps, and we would ask ourselves, what's the business impact if this fails? What kind of a loss are we going to realize? What is the probability of this failing? And there are a lot of different factors that it can impact that. So this approach is what we are going to be discussing during today's webinar. So why would you want to perform risk analysis? Well, by performing risk analysis, you are able to identify the high-risk application components that must be tested more thoroughly, as well as those that must be identified and tested more rigorously because perhaps they're error-prone. So you've had a lot of problems in the past. It also assists in determining the testing objectives during test planning. So while we're creating our test plan, we can determine, hey, wait a second, these particular test cases have a higher risk score. So let's make sure we allocate a greater number of resources to validating these test cases with that risk score, or let's at least allocate the resources that have that has a greater amount of expertise and experience. Also, performing risk analysis will assist in prioritizing our testing efforts to test high functionality first. So I'd like for all of you to think back during the years in your experience. Has there ever been a situation where you've had to communicate to your leadership that you were not able to execute all of the regression tests? So how did that make you feel? What was the reaction of leadership in that situation? So don't you think leadership would feel better if you were able to say, hey, we weren't able to execute every single test case, but the great news is we were able to validate all of our high risk and medium risk test cases. So you can at least rest easier knowing that. There are a lot of other benefits, specific benefits to risk analysis as well. So it allows you to run tests in risk order. So the great thing with that is that it enables you to find the scary stuff first. So by testing that functionality, which has the higher risk score, if you find any issues, again, you find the scary stuff first, and the great benefit to that is it enables your development team to resolve the issue earlier. It also, if you're thinking about target dates, provides them more time to resolve the issue. It allows you to allocate the test effort based on risk, so you can pick the right test that you're going to execute. It's, my many years in QA and software testing, it always amazes me when I ask an individual, they will share with me what their plan is and the sequence in which they're going to execute their test. And I'll ask them, all right, well, great, why are you executing that test next? If there's no dependency, why are you going to execute that test? And they will have no good reason. So you've got to be strategic, and it always helps to have a valid reason as to the order in which you are executing your test. So by executing them based on risk, that is strong justification. By utilizing risk analysis, you're also enabling your leadership to make much smarter release decisions. So they can decide to release once the risk of delay balances the risk of dissatisfaction. So think about it. You want to know, all right, is my end user going to be more upset with me if we release this application, this system into production with these defects, or are they going to be more upset if I resolve those defects but I'm perhaps a few days late. By performing risk analysis and having risk scores, you can better educate the end user, provide them that information, and the end user and leadership can make a much smarter decision. And then if the schedule requires, you can drop test in reverse risk order. So you absolutely know that you and your team are not going to be able to execute every single test case in your plan. It's just not possible. And you also don't have the option of adding more resources. So by performing risk analysis and assigning a risk score, it gives you the option of sacrificing those test cases with the very lowest risk score. And remember, a risk score involves both impact as well as probability, and we'll talk more about that as we go.
Bob, if you don't mind, let me jump in for a second. We've had quite a lot of people join in the past 10 or so minutes. So for the people that didn't hear the intro, we are going to have a Q&A session at the end of this webinar, but feel free to type in any of those questions you have along the way into the chat, into the questions panel. We may interject some here or there, but put them in as you're thinking of them. So we don't want you to have to wait until the end before you start typing in all those great questions. Sorry to interrupt, but I just wanted to throw that out since we had so many people join. And this is being recorded, so you will receive a link to that.
Absolutely. Thank you, Brent. So right now I want to share with you the process to develop the risk analysis process. So the first thing that, if your organization does not have any sort of risk analysis process in place, the first thing that you want to do is create a risk profile. So creating a risk profile involves identifying the numeric ratings, if you will, that you're going to use for impact and for probability. It also involves developing an assessment questionnaire. So you want to come up with certain questions to help your team, as well as perhaps help the end users, determine both the impact and the probability. So it might be questions such as, has this particular feature or functionality been a problem in the past? How many users utilize this function or this feature in the application? So things along that line. The next step is that you would actually start assigning risk scores to the granular assets. And those assets, you could do it at the requirements level, if you're utilizing RBT, requirements-based testing, or at the test case level. And we're going to discuss the whole scoring process in greater detail as we go throughout the webinar. You want to make sure that once you've done this, that you compile and maintain a risk assessment database. And that improves the whole process, and it helps management plan development projects. So it helps them take a look at the legacy, the different systems they've developed and implemented in the past, identify the risk they had then, which they may very well have now. So it allows the whole organization to be much more proactive. And then last, you want to make sure that you revise the risk profile as appropriate. You may start to realize that there are other factors involved. Maybe it has to do with technology, maybe it has to do with people, perhaps it's processes, but there might be other factors involved that cause you to revise your impact scores or probability scores. So in assigning risk scores, I'm going to discuss this at a high level right now. The first thing you would do is assemble your assets. So assemble your list of assets on which you're going to apply the scoring to. For each risk, you then determine the impact if that risk actually happens. So if we're looking at a requirement, we would ask ourselves, okay, if this requirement fails in production, What's the impact to our organization? So if I'm looking at the requirement which states that a user shall not be able to log in with an invalid password, we've got to ask ourselves, what's the impact to our organization if somebody is able to log in with an invalid password? And then for each, we're going to determine the probability the risk will occur. What's the likelihood? And a lot of different criteria based on that. If it's brand new technology, the probability is typically higher. If we've had numerous problems in the past with that functionality, if it has failed in production quite a bit previously, then the probability is higher. But if it's a more mature process, a more mature feature, then our probability, the likelihood is lower. And then you want to calculate the risk score, and that would be a combination of utilizing the impact and the probability. And we're going to talk about different formulas that you can use shortly. So with the risk analysis, I've been mentioning these words impact and probability quite a bit. Remember that with the impact, you're not necessarily talking about just the black and white loss of money there, but you could also be talking about loss of life. Or with impact, is it simply an inconvenience for the end user? Not that that's a good thing. I don't mean to make light of that, but that's something that you would want to understand when coming up with different ratings. With the probability, as I mentioned, is it new functionality or new technology? Has it been tested ever before? So these are all things that you want to look at. When it comes to ratings, you can decide, we're just going to keep it simple and use the numbers 1, 2, 3. 1 for low, 2 for medium, 3 for high. And I've been in organizations where they use scores of 6, 4, 2 for impact and 5, 3, 1 for likelihood, just to give it a little bit more weight. And I've been in organizations where they will come up with the ratings for impact and probability, and then either add the two to come up with the final risk score, or they multiply. And there are definitely advantages, which I'll talk about shortly, in multiplying. So in coming up with what the different risk might be that you want to consider for your assets, this is just a partial list which exists in the book, A Standard for Testing Application Software by William Perry. So for those of you that are not familiar with William Perry, he actually started QAI Worldwide, Quality Assurance Institute Worldwide, a great organization, fantastic organization. They're responsible for the Quest conference every year. So in looking at this list, you would ask yourself, all right, for this functionality, is it complex? So is there a lot of code? Is the size of the code significant? Because that will more likely impact the probability. Because when a modular has a lot of code or it interfaces with a lot of other modules, again, that is much more likely that there's going to be a problem, if you will. We talked already about whether or not it's new technology, but some other things that you would be looking at is the upstream dependency, perhaps. So by upstream is the process that you're performing the analysis on now, is that process upstream of other processes? If so, if this process fails, then you know that the other processes are going to be impacted, so that increases the impact. If the functionality or the process you're looking at is downstream, so maybe you're looking at process C, and you know that process A, so C is downstream from process A has had a lot of problems. So you know that's going to increase the probability or likelihood. So again, all factors, this is just a partial list, but definitely check out the book for a much more extensive list of generic risk that you would want to take into consideration. So here's just a quick example of some risk scoring fields where you've got to have at a minimum, you've got to come up with ratings for probability, remember also known as likelihood, or impact, also known as criticality. Another optional field is to look at the exposure, which we talked about earlier. So you could keep it relatively simple, come up with just the 3 values which we discussed. The disadvantage to that is it might be a little bit too simple. Or you could come up with 5 values. So 5 for critical, right down to 1 where it's negligible. And it provides for a much more granular rating. So some variations on that is you might want to provide impact, let's say, with a greater weight. We're going to have an example in just a moment where I share with you a process where if you wanted to utilize a weighting factor, you could certainly do that. So for risk calculations, here are just a few examples where if you're adding the criteria, obviously the risk score would equal the impact plus probability, or if you wanted to add a separate score just for the exposure on that. You can also multiply the criteria, and the great advantage to that is when you're multiplying, you start to get a much wider, more granular disbursement of the scores. So that allows for more obvious clumping. So by clumping, what I mean is in just a little while, I'm going to show you a grid, a quadrant, where it has 4 different quadrants, and you plot the scores in the quadrant, and then you test in that order. So I'm going to show you that in just a moment. But it makes it much easier when you multiply. You're not going to see as many of your scores all clumped together. So one thing, as you're developing and implementing a risk analysis approach, you've got to ask yourself, when would you consider a risk acceptable? A number of years ago, I was involved with Harris on an FBI project, and it was a heavy messaging application. And one of the defects that was discovered was it was in regard to the formatting of the message, and there was a semicolon instead of a colon. So obviously something like that, it didn't impact the meaning of the message. That was a very, very low risk. So that was something where for the resolution, we were able to defer that. So the risk was rather or somewhat acceptable. You'd also want to think about, besides risk, what other criteria might impact priority. Because when you think about risk versus priority, well, they're not always one and the same. So sometimes you've got to think about target dates that will impact the decision. You might ask yourself, are there any available, acceptable workarounds? And how easy are they to implement? What about management? What about customers? So I mean, think about it. If we've got something where the risk score is relatively low, but leadership comes to us and says, hey, no, regardless of what the risk score is, that is very important to the customer. You've got to give that a high priority, test that functionality. So obviously in that case, priority is going to override the risk score. So there are 3 different steps to scoring an application. The first is determine the impact of failure. Then you're going to calculate the probability score, and then plot the scores on a risk analysis chart. So once you've followed those 3 steps for scoring, you're then going to use the results to focus the test effort by plotting the risk scores into a quadrant. And there's a lot of software out there that does this, by the way. So this is something you can actually utilize Micro Focus's ALM and Quality Center for. So first, you would focus on the components in quadrant 1. Second, focus components in quadrant 2. Third, component 4. And fourth, on quadrant 4. And actually, and I apologize, actually, a slight mistake there, because we're going to plot our highest impact, highest probability in fourth. So when it comes to executing, we're actually first going to execute those tests that are in quadrant 4. So let me show you an example. So here's a great example of a list of our ratings for impact of failure. So notice that this is very, very detailed. We've got ratings of 0 through 10, with 0 being no impact. So we're saying, all right, if this feature or functionality fails in production, then there's no impact to the end user, no impact to the organization. Whereas a level 5, we're saying is moderate impact, little monetary loss, workarounds are needed, so they haven't been developed yet. Right down to 10, where we're saying, hey, this is a major impact, major loss, no workarounds available, customers notice, company-wide processing is halted. So as you can imagine, that would be a critical, high-impact loss to the organization. So you don't have to get this granular, you don't have to get this detailed and come up with this many scores, but it definitely makes for a better process. Then we're going to decide on how we're going to score probability or likelihood. So what's the likelihood? What's the probability that we're going to have a problem with this? So notice in the example that I'm sharing with you here, we are utilizing weighting. So in other words, we've determined there are 3 very important factors when it comes to calculating or determining the likelihood of failure. And those 3 factors are complexity. What's the size? How complex is the code? Does it do a lot of branching? And we're going to give that a weight factor of 3. Frequency of use. So we've determined, perhaps this is an ATM, and we know that at ATMs withdrawals are performed a lot more than deposits. So with frequency of use, we're going to give that a weight factor of 2, and then new functionality, we're going to leave that as is, and that just has a weight factor of 1. So whatever we determine the score, and then we're going to rate our components on each of the 3 factors. So high, medium, and low. So notice down at the bottom, and I'm sharing with you right now, by the way, everybody, I am sharing with you what I would consider to be a relatively complex approach for risk analysis. I think it's fantastic. If you have the time and the expertise to utilize this process, I highly encourage you to do so. But very shortly, I'm going to show you a much simpler process that you could use as well. So down at the bottom, once we've scored some functionality on each of these different factors, we would then use the formula where we would take the whatever score, 5, 3, or 1, times the weight of 3. And again, I'm going to show you an example in just a moment. Plus whatever rating score we give it for frequency of use times 2. And we're going to add it to whatever score, whatever rating we give it for new functionality. We are going to add those and divide by 3. That then gives us a rating for likelihood or probability of failure. So here's an example. Imagine, if you will, we're going to take a look at these 3 different modules: shopping cart, payment process, and order queries. So for the shopping cart, that module has to do with selecting items and obviously purchasing them. In this example, we've given it a low rating for complexity. So in this particular application, we've said, you know, the code to select and purchase an item really is not that complex. So we're going to give it a low, but remember, it does have a weighting factor of 3. Complexity does. Then for frequency, we're going to give it a 2. And then for new functionality, so maybe this particular feature in our application, it's brand new, we've given it a high score of 3. So for the probability score, once we've multiplied and added that score, that equals 10 divided by 3, and that gives us a 3.33. And then previously we determined that the impact score is 7. So let me go back for just one moment. And 7 is moderate impact, significant monetary loss, workarounds needed, customers notice. So that makes perfect sense if we have a problem with our shopping cart. And then we do the same process for payment process and then for order queries. So you see we've come up with a probability score of 3.33 for shopping cart, 6.77 for payment process, and 5.1 for order queries with impact scores of 7, 10, and 4. We would then take these ratings and we would plot them within our quadrant. And once we've plotted our scores, we would then focus our testing effort, first tackling quadrant 4, and then 3, and then 2, and lastly 1. Very, very effective way to improve your testing process. However, seriously, how many organizations have this kind of time to implement such a process? It's a challenge. And it is something that if you're able to do so, what I would highly recommend is start utilizing this process with new projects as they come along. So I am not saying to you to go back to all of your legacy projects and applications and implement this kind of a process. But for new projects as they come along, it's something that it is not as painful to implement if you start with new projects. However, if you've got projects already in place, you know, one of the things that you really need to look at and respect is your intuitive understanding of the application. So in this type of what I refer to as rapid risk scoring, the idea is that you're going to get a team or a designated group together. So one thing you want to make sure of is that you have this team, this designated group that you've created. They should have a reasonable amount of subject matter expertise. They should understand the business, understand the application. You then give each group a card with scores of 1 for low, 2 for medium, 3 for high, or 4 for very high. So these are risk scores, by the way. And you can make it more granular, come up with more numbers if you want. You then have a spokesperson describe each process, each requirement, each test case, whatever the asset might be, but they describe the asset, and as they're doing so, each person will quickly hold up one of those risk score rating cards, and you would then average the scores. So perhaps you have 6 different people, you describe a process to them, and what you will be surprised is how close everybody is with scoring the risk. The greater number of people, the more effective the process is. And one thing that you might want to do is say automatically, okay, you're going to eliminate one of the high scores and eliminate one of the low scores, and then average the rest. So in other words, everybody is utilizing their gut instincts, their intuition, which is something I've always found you've got to respect. So we're actually going to go ahead and perform this exercise in just a moment. So I'm going to give you all a chance to do this. So imagine, if you will, that we've got 4 different processes. And we're going to utilize risk scores of 1 for low, 2 for medium, 3 for high, 4 very high. So let me go through all 4 of these different processes here. We've got a login process where we can successfully log in. The functionality we're testing is that we can successfully log in with a valid username and password. And that for that login process, we cannot log in, and that we would receive an error message with an invalid name and or invalid password. And keep in mind, with this login process, with our application, a user must be logged in order to perform any other function in our application. And the login process is performed more than 10,000 times per day. For process B, that is a product inquiry. So that's a query, if you will. So that's the happy path. So that's the query. It's a happy path. It's performed 8,000 to 9,000 times per day, where a person might just do a quick query on a specific product. They want to see if it's in stock. Process C is the order checkout. It includes the process includes the acceptance of payment. And it is performed 3,000 to 6,000 times per day. And then the last process is the product return, so the refund. So that includes and processes the payment refund, and that is performed 100 to 500 times per day. So we've got these 4 processes: login, query, checkout, and refund. So Brent, I'm going to turn it over to you for the poll.
Yep, so I'm going to basically launch this poll, and given what Bob has just mentioned, the scenarios that he said, we put a few of them kind of in orders from very high to low, and all we're asking you to do is just to kind of rapidly select which ones you feel like go from very high to low. So make those selections now. You should see the first option is checkout, then return, then login, and then inquiry. Again, this is going from very high to low. The next one is login to checkout to inquiry to return. The next one is login, inquiry, checkout, return, and so on. You can obviously read them.
So you're asking yourself, if this functionality fails in production, what's the risk to our organization?
So we're going to give the audience about 10 more seconds to answer. We appreciate everybody's feedback so far. All right, and I'm going to go ahead and close that poll and display the results.
All right, so fantastic. So no real surprises in that close to 50% of you chose exactly what we really would have expected, and that is that the login would have the highest risk score, because keep in mind, if you're not able to log in, then you're not able to do anything.
Which includes inquiry, checkout, and return.
Exactly. And if somebody is able to log in with an invalid password, then just think about the damage they could possibly do to our organization. The second highest risk I would expect to be checkout, because that involves the organization, that involves a potential loss of revenue. And again, if you hadn't been able to successfully log in, you wouldn't be able to do the checkout either. And then the third would be the inquiry, because of the amount of frequency perhaps. And then the last would be return. But one of the things to keep in mind with this rapid scoring process is that you're providing your organization, your team, an opportunity to discuss it. So if somebody feels strongly and says, hey, no, wait a second, checkout should be the higher score, then it gives an opportunity for everybody to discuss it. So this can be done, again, in a relatively quick fashion, and it's easy to implement. So with that being said, we are now going to open it up to questions, and we will take as many questions as we possibly can. We've got close to 10 minutes, and Brent is going to be our moderator for questions.
I appreciate everybody's feedback and questions they've submitted so far. Let's kick it off with this one. This is a great question. If a company conducts a formal risk assessment once per year, is this enough?
You're right, Brent. That is a great question. So that really depends on the frequency in which new assets are being added to the test plan, and your risk scoring, your risk analysis process. So if you're basing it off of test cases, what I strongly recommend is that as test cases are designed, that is the time to apply your risk analysis process and come up with a risk score. You will find that it significantly decreases your level of effort if you are performing risk analysis on the assets as you design, develop them and add them to your test plan.
Great. Okay, next question. And I think you kind of touched on this a little bit, but how do you measure the avoided costs or even the ROI from taking a risk analysis approach?
Excellent point. So that can be one of the challenging things to do, because that's what I would refer to as, I think everybody has heard the term risk avoidance. So in this risk analysis process, we are not talking about a time saving. We're talking about improving your process and as such, delivering more perfect software into production, thus avoiding the risk and the potential impact to your organization. So the best, one of the things that you can do is start keeping measures and metrics now, and also whenever a defect occurs in a production, somebody should keep track of truly the impact, the financial impact, whether or not it has to do more with public relations, etc. What's the impact to the organization? Measure that now, and then when you're able to find defects that you would credit to your risk analysis process, then that gives you a good way to measure your ROI and report that to leadership.
Gotcha. This is a great question. Who all should participate in risk analysis? Developers, testers, BA, etc. And I don't know if that was particularly speaking on the rapid risk scoring or the more in-depth approach, but I think that's a great question.
Sure. So let me talk about both first. So if you've got a formalized process, more robust than the rapid risk scoring that we showed there. So what I would recommend, so one of the things, we'll have another webinar another time, but I love I love walkthroughs, peer reviews, code inspections. That is a great time there to discuss the risk analysis and risk scoring. And also in those peer reviews, it's typically where you are going to have team members with different skills.
Mm-hmm.
So you would have probably an end user, you would have somebody from operations, you would have a subject matter expert. So anytime you can get those individuals involved, you're simply going to add value to the whole process. I would also say try to include some of those same individuals if you were utilizing the rapid risk scoring approach that I shared with everybody. So again, anytime you can get those individuals in, it will give you a much wider view, and it just pulls from a wealth of knowledge across the business.
Very good. And I think you started on this in the beginning of the webinar, talking about building your case, and you're talking about how would you feel if certain requirements didn't get tested, but you can go to your leadership and say, well, but at least I tested the ones in, say, quadrant 4 or quadrant 3. But the question here is, what issues do you see with trying to get buy-in to take a risk approach, and any suggestions to overcome those issues?
So the number one objection, which is real, I mean, it's a good point. If leadership, says to somebody, well, hold on a second, that's going to, that sounds like a significant level of effort for you to implement. How much time is going to take that? How many resource hours are we going to have to utilize? So the way to overcome those kind of objections is to perhaps start on small projects, mm-hmm. especially if you're going to utilize a very robust approach. Do that, track the measures and metrics so that you can report on some kind of an ROI, so that you can go back to leadership and say, hey, look at the benefits. I honestly don't believe we would have tested this so early in our testing effort had we not used a risk analysis approach. So share that with them. The other thing, if that doesn't work, then start with the small project and utilize the rapid risk scoring approach. And just, again, emphasize to leadership, the ROI and just some of the additional risk they'll be able to avoid by doing this.
Great. We've got a few more minutes, so let me try to sneak a couple of questions in. You mentioned ALM Quality Center helps with plotting risk, but is there any open source tools that will do this?
So I know that some of the, if I'm not mistaken, I believe Blueprint, which is a requirements collaboration solution, has this kind of functionality. I believe several of those do.
Okay.
I'm not familiar with any other test planning solutions other than ALM and Quality Center where you can do it at the test case level. However, that being said, I know that a lot of the other test planning solutions, those by QA Symphony, Q-Test, for example, I know for a fact that those are easily customizable,
right,
so that you can implement just such a process.
Okay, that makes sense. Let's see, got a couple more minutes. My organization hasn't been hit with any kind of issues or surprises, so why should we change our approach?
For that, I would say probably, I haven't been in a car accident yet, but I still have car insurance. So I mean, that's, I'm still alive and walking, knock on wood. I still have life insurance. So for that very reason right there, I mean, it's a, it allows you to improve your process so that you don't run into these issues.
I'm sure a lot of people have had that conversation about application security testing as well.
Right.
All right. Well, let me get one more in before we move on. Would you score differently across different levels of testing, i.e., unit, integration, systems?
Oh boy, I love that question. You know, I would not. You could. I just, I think you might be biting off, you know, more than you can chew in that situation. Because, I mean, ultimately, what you want it to be about is the impact to the business. And that should be the same across the board, because you're talking about the impact and improbability of failure once it gets into production. If you start doing it at the unit test the level, let's say, and the thing you're really doing there is you're talking more about the impact to the individual, to the developer, or to the tester, or to the test team. And it's all about the business in this situation. So I'm not saying not to do it. I can think of some cases where it might be beneficial, but I would highly recommend you just keep it focused on the impact and probability relative to the business.
Perfect. So before we close out, just wanted to do a little bit of business and who we are. We are Checkpoint Technologies, for anybody who wasn't already aware of that. I did want to mention, so we were incorporated in January of 2013, or 2003, I'm sorry. So we're actually celebrating our 15th year this year. Very proud of that. We basically specialize in QA and QC, focused mainly around functional, performance, and application security testing. We're proud partners with Micro Focus, Atlassian, Mobile Labs, QA Symphony, and Zephyr, as well as QAI training partners. So Bob had mentioned QAI a little bit earlier. QAI is Quality Assurance Institute. They handle a lot of training and CST prep courses, that sort of thing, as well as they run a fantastic conference, Quest. This year, Quest in April is going to be in, I believe, what is it, San Antonio, Bob?
Correct.
So if you have a chance, attend that. It's a fantastic conference.
Just remember the Alamo. and you'll remember where Quest is.
There we go. So some of the services that we provide at Checkpoint Technologies, we do a lot of staff augmentation, whether you need short-term or long-term services, on-site or even remote, things like QA leads, manual testers, automation experts, that sort of stuff. Consulting as well. We do a lot of audits, assessments, QA process assessments, configurations, analysis, all sorts of things. Outsourcing as well. So if you need some testing expertise to be part of your team, we can handle that for you here. As well as training. We do quite a lot of training, QA, on quality assurance, just general topics, software testing, as well as some very specialized training as well on specific tools and that sort of stuff. We can handle that on site at your location, virtually, and we also do some public training as well. And then finally, mentoring, which is essentially training in your environment in your tools where real work actually gets done, and it's also a little more cost effective as well. So with that, I want to thank Bob for giving the presentation. We're going to throw up his contact information here as well, so feel free to email him.
Yeah, please feel free to email me any questions, and then I also am on LinkedIn, so please feel free to connect with me on there, and thank you so much for joining us today.
Yep, with that, also real quick, we value very much your input on these webinars and how we can make them better. So there will be a survey when you close out of here. There's about 6 questions, I believe. Please take that survey. Let us know how we did. They're quick, easy, rate 1 to 5 sort of questions. So we would really appreciate that. Again, this was recorded. You'll receive a copy of that recording sometime tomorrow. And with that, everybody, thank you so much and have a great rest of your day.
Have a great day. Thank you.